Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 3 of the lesson on solving exponential equations. And we're going to look at one more example where we're asked to give the answer in terms of a specific ln, in this case ln 2. The equation we're solving is 8e to the power of x over 3 plus 11 all over 3 equals 5. So as before, my first stage is to isolate e so that I can use ln, the inverse operation. I'm going to multiply both sides of the equation by 3, giving me 8e to the power of x over 3 plus 11 equals 15. Subtract the 11, which is 8e to the power of x over 3 equals 4. And then divide by 8 to get e to the power of x over 3 equals a half. Now, I've got to the point where I've got e on its own, so I can ln, which means that I've now got x over 3 equals ln of 1 half. But I don't want ln of 1 half, I want it to be in terms of ln 2. So I need to think, okay, how can I write 1 half as base 2 with a power? And the way that I can do that is I can say that 1 half is 2 to the power of negative 1. And then using the powers rule of logs that we explored in part 2, that negative 1 can come down to the front, which gives me x over 3 equals negative ln 2. And then the final thing to do would be to multiply by 3, which is going to give me my final answer that x is negative 3 ln 2. Now this is really common in problems involving exponential rates of change and in a topic you'll meet in the second year of your A-level called differential equations. You get to ln of a fraction, generally 1 over a number, and you need to be really hot on the idea that if it's ln 1 half, that's the same as minus ln 2. If it was ln 1/5, that would be the same as minus ln 5, and you need to become fluent in realising that and applying this rule to get your answers in terms of a specific ln. Thank you very much.